Well, I want to go ahead and jump right in and welcome our speaker, Paskal. Greg and I met a few months ago when I did a talk on testing. And I said I did a talk as someone who doesn't know the subject, and I'm really excited that this time we have someone who knows what he's talking about. Greg has certainly done a lot in the world of automated testing, and he is here to share some of that knowledge with us today. So I'll hand it over to him.
Thanks, Greg. Man, this room is full. Thanks for coming out, everybody. Agile, BDD, DevOps, landscape at the Star West conference was packed with all these terms I'd never heard before. It was really cool because I got a chance to go to Anaheim and speak at this conference on a testing topic. And you know when you go to a conference and you attend that one session, you're like, this made the whole thing worth it? I had one of those sessions like that. And it was fantastic, and it made me think about testing in a whole different way, and I really loved it. And that's really what I'm going to share with you today. It really made that whole trip worth it. Well, my name is Greg Paskal, and I work for Ramsey Solutions, and I love working where I'm at. I just moved here from Dallas with my family in January, and so I've been with the company for just about 7 months now. It's been fantastic. You know, I got my first computer, if you can believe this, maybe looking out here, some of you guys did too. It was in 1980, and it was a Commodore VIC-20. Anybody have one of those? All right, couple guys. And I remember begging my parents, please, I need this computer. And they're like, what in the world are you going to do with a computer? You're only 16 years old. And I said, I don't know, but I just got to have one. And I got that thing. I remember, I can still see the box now, open the lid from it, right, Bill? Remember? You peel that thing back, and there's that computer. And in there was a book. And in the book, it taught me a language, my very first programming language called BASIC. And there was no way to store anything on this computer. At least the version I got was just the basics. It's amazing to think my parents somehow forked out $300 at this period of time to get it, because that was a lot of money. And I went through that book that they had in BASIC, and I typed every program in. I remember the really cool ones. I'd leave the computer on all night long because there was no way to store it. And then I would turn the black and white TV on the next day to kind of play with it some more. So programming has been something since my first inception. I really love it. And I've had a real great opportunity to continue to learn languages. I don't know how many of them I've learned so far. I find some of them are like, what is this strange thing? It's like a beast I've never seen before. And the others are like a familiar friend. And so some of you who know more than one language, you know how that is when you're kind of moving across a new one. I'm learning Ruby right now. Fortunately, a lot of that feels familiar, but there are other aspects of it that don't. So it's remarkable that that was 36 years ago, that first computer. I still think it's in the rafters of my mom's house out in California. So pretty cool. In the 1960s, NASA decided to create what was called Project Mercury, and it had a few distinct objectives. The first one was to get a human into outer space. The next one is, could a human, could we function? Could they work and do normal kind of Earth-like things if they were in space? And lastly, could we get that poor guy back to his wife along with the spacecraft we just spent millions of dollars to build? And so you can imagine that was a pretty big amount of risk involved. And so NASA decided, hey, we need to come up with a testing plan, some approach to ensure safety, to reduce the risk. So they put into place this idea of testing early and testing often. And believe it or not, out of that was born the idea of unit testing, as you and I know it. It's got some cool roots. I love that kind of stuff. Thinking about that, it was founded in kind of the days of the space program. So what is unit testing? Well, typically we know it as part of the software development lifecycle. It's all about testing those smallest pieces, those functions is what I started with, methods. Those small pieces of code that need to be tested. It's all about assertions and validating that things are operating properly, including the exception handling, the things that are supposed to catch those things when someone enters the wrong information, the wrong data. Well, if you think about it, there's a traditional approach most of us have probably been exposed to in testing. I know I have most of my career. And it goes something like this. You've got this manual testing at the UI layer, the user interface. It's a huge bucket of tests. I mean, it's gigantic. I've been at some companies. I was at FedEx. I remember the amount of test cases. It looked like the yellow pages. It was ridiculous. And so some of you have seen that too. You have a testing team. They're doing everything they can. They're writing test cases all day long, and they're building this enormous stack of tests. It's also a lot of ad hoc. For a young shop, a team that's just getting started, will usually wind up going ahead and applying some ad hoc. And there's this mindset, oh my gosh, we have to test everything. And that, a lot of times, is the traditional approach to testing. Typically, you have this integration layer, and so often I see it like this. There's no owner, and it comes up like this. Oh my gosh, did anybody load test this thing? Did they make sure that the firewall is open in a certain way so that this thing could talk to that thing? But oftentimes, this goes as the afterthought. And the last piece of that is the unit test. It's usually very minimal. Sometimes it doesn't exist at all. A lot of times in the dev space, the thought is, hey, that's QA's job, testing is their job, I don't need to worry about that. So this is really probably the most common testing approach I've seen through many, many companies I've been at. I imagine you guys have as well. One of the things I think about when I think about the traditional approach is it's pretty screwed up. It's like we've got the picture completely backwards. It doesn't take much reasoning to realize if you do the testing at the very end, you're going to have an enormous mountain to climb. The logical thing is to do it earlier on in the process. And so when I got to go to that presentation last year, that's really what this guy started to teach me at this one session. It looks something like this. Strategic, intentional testing at the unit test layer, at the low-end layer. It was built by devs. It wasn't built by QA. These guys, they know it. We know how the code works, and so we know how to write that test. And it's not trying to climb Mount McKinley. It's solving a small problem. It's climbing an anthill. It's checking some very small things. Then we have this next layer, and I'm learning a lot about this piece here, which is the integration layer. And it includes using things like automated and tools and things that can validate that our systems are talking. There's a lot of opportunity to still grow here. We're exploring some opportunities for what I call environment validation and areas like that can really help us to do integration testing a lot smarter. And this last one, which is really where I spend a lot of my time, is up in the manual and automated. I know there's some manual testers here. Who's a manual tester? Just curious. I know we got a couple of them here. In the manual space, you notice how this thing is so much smaller than it is down here. And that paradigm is intentional. Because remember we had it before, we had that pyramid upside down. That thing is going to fall over. We've got all this heavy space in the UI space trying to solve the testing miracle, which is to test everything and let no defects go to prod. It's an unrealistic expectation. Here, we have a very intentional manual test strategy. I work in the automated space. That's where I live. I'm going to share with you at the end of this presentation a link, and I'm going to show you a quick image here as well. If you have a manual test team in-house, I'd recommend you go send them to this link. It's worthwhile. And it ties in with the methodology called METS. We use it at Ramsey Solutions. It stands for Minimal Essential Test Strategy. And of course I like it. It's something I created out of necessity when I worked for, at the time it was Kinko's, and I owned Kinkos.com and making sure stuff was working before it went live. And I had to make sure that stuff worked well. So I came up with an approach. Basically, you can kind of see an example here. You're not really meant to read this, but you can get examples of this online where you have a critical, high, medium, and low test. You prioritize your testing. But I love this idea that we do this unit testing. Like, that's where the bulk of it is. These are not gigantic applications anymore. We're testing those small methods, those small functions, and that sort of thing. But today I want to teach you 3 really easy test techniques. Everybody in here can get a grip of these. And they're going to change the way you do your unit testing. It's going to improve the quality of your product. I feel real confident about that. Really easy to understand. So let's jump in on those. All right. The first one is this idea of positive testing. Most devs refer to this as happy path. In the testing world, we call it positive testing. The whole idea here with positive testing is to verify the expected result of what you expect that method to do, that it does it. I created this real simple number line, and I want you to think for a minute if you had a method or a function called add, and all it does is it takes two inputs, sums them together, puts the sum value into a variable called result. Okay? And some of the requirements of the add method is that the number has to be between 0 and 10. Anything outside of that is going to be an exception. Pretty basic, right? You could probably write this thing in less than a dozen lines of code. So here's a good example of a positive test case. So let me go back here one. A positive test case would be if we put the number 3 and 4 in. And our inputs, we're going to get 7. It's real simple. Our positive value is going to line up at 7, and that test is going to pass. Pretty much piece of cake. The next one's not much more difficult, the negative. This is the second of the 3, a negative test. It just verifies that the expected invalid result comes up. It's those exceptions. That's your exception handling. You want to test that. Believe it or not, this is one of the more common ones that doesn't get usually added in at the unit test layer, but it's really, really important. Okay? So we're going to take that same add method, and let's imagine that we had two numbers. Okay, so we're going to go ahead and look at our same number line here, and I'm going to highlight where that negative testing is going to test. It's really intentional to hit these areas of the method. So in this case, our input data will be 3 and 9. We're going to get a 12. That's a perfect example of a negative test. It's going to fall out here. We should see our exception handling coming back in some way. By the way, there will be you'll be able to download these slides later. I'm going to have them on a site, so I'll give you the URL at the end. All right, the last one. This is kind of a cool one because it's a combination of the first two. It's called boundary test. This test really verifies that you're getting valid results at the edges of things, where one thing transitions to another. It's very intentional, this test. And I took that same number line and I enhanced the areas where boundary comes into being. You can see where we transition right into these areas from our positive to our negative test case. If you're intentional with your boundary testing, you're checking that area right where you switch over to the next. So we'll use another code example using add. We're using our add method. We'll put our first input number in of 9 and 1. We're going to wind up with 10, and we're going to hit this boundary right here. It's also a positive test case. Okay? Then we're going to go ahead and use our second value, which is going to be a 9 and 2. It's going to be an 11. So we have really potentially 2 of what are going to be 4 boundary tests. We're going to cover those in just a moment. So far, so good? Everybody following? All right. So here are the 3. I have brought some of these for you, and I have the PDF online too. So if anybody wants some of these after class, come up and take them. But this shows the three areas of testing, and this simple idea of adding these 3 to your unit test strategy is going to make a difference in the quality of your test, and it's going to give your confidence across your life cycle folks, from business test, QA folks, whatever, that you've got a broader coverage in there. Yeah, I made a note here too as well that one of the things I've learned as I've written automated tests, and I think it applies in unit tests too, is after a while you're going to find there's certain patterns of test as well. If you think about this add unit test, probably a subtract unit test is almost going to be the same. And I have a feeling as I explore it more and learn more about it, there will be standard patterns that we would use in these unit tests. So in automated tests, I find there's a process I call climbing the N-curve. And basically, it's brutal when you first start. It's like climbing Mount Whitney. And it's because you're developing all those patterns or all those basic tests. And you begin to crest that thing, and you get that reusability, and it becomes a lot easier. So as you're starting to consider these tests, realize you're going to hit that N-curve effect where it's going to be like climbing uphill for a little while, and you'll build those patterns. It's probably a good idea to build a library in your wiki or whatever tool in your GitHub space to begin to put these patterns of unit tests that can be reused. So I wanted to do some code examples and show you what these would look like. Now these are super simple. We'll start with the method. This method's written in Ruby. This wouldn't look much different. It was in most of the other languages we're probably all working in here. We've got a class called adder, And we've got our method in here called add. It just takes two input parameters, sums them together, and puts that sum in a variable called result. It does some validation. Remember, our requirement is that the number is greater than 0, or 0 and greater, and less than 11. So if it runs into those exceptions, it's going to throw these errors, and it's going to return the result. So our positive unit test example looks something like this. We've already talked about this number line. I've added a table for some test data now. I like to document this. You know, it's funny, a lot of managers I work for are crazy about documenting test data, and this is a method I use a lot. If anybody's interested in that, I'd be more than happy to share some kind of mature versions of a table like this that is broken down by screen. So in this case, our test case 1 is going to have these two values. Super simple unit test here. It's literally 3 lines if we took the comment out. It's going to assert that we get a 7 after we pass in our 3 and 4 input parameters, and it's going to give us a pass. Anything outside of that 7 is going to fail in our test framework. In this case, I'm using RSpec. It would be pretty similar with JUnit. So let's look at the negative example. In this case, I'm going to have 2 test cases I'm going to put in, because I'm going to test both sides of this. So my test case 1 is going to look something like this. Again, I'm documenting the type of test I'm going to perform, my assertion here, with my 2 inputs of a 4 and a -8. So we're going to get a value of -4 coming back, and we know we're going to be in this spectrum. And what's interesting about this negative test, it's going to pass, right? We're checking that the exception handling is coming back. That's the important part of this test. So don't be fooled by a negative test has to fail. It passes to prove that we've coded it proper. Make sense? And here's the complementing one, where we're checking at the other end. Again, our same assertion here of 4 and 8 is going to give us 12, and we're going to hit our over limit result exception. Pretty straightforward, right? Okay. So, of course, we've got now this boundary test. In this case, I've got 4 of them. I kind of think of this like a sandwich. I was sharing this with some guys in the office the other day, and it hit me that these tests are kind of grouped together. So we're going to perform these 4 tests, and you're going to see us walk through it. The first one's kind of like the bread on the end here. So we're going to have our input data. Here's what our unit test is going to look like. Where we're inputting 0 and -1. Our result is going to wind up right here, and we're going to get a pass in this case. We're going to go ahead and step into our next test case. You can already tell where this is going to go. Oops. It's going to go into this second one. We're going to add 0 and 0. We'll hit our 0 space. We're going to wind up right here. And then our third one, pretty similar. Here's our code example. Again, it's a positive test, notice, of adding 9 and 1 to get 10. We're going to wind up way over here on this end. And you can see where we're going to cap it off with that sandwich, that boundary test sandwich, by putting our 9 and 2 and hitting right here at our 11 for our negative test. Boundary tests are so important because that is generally where things are going to fail, right at that transition point. It's really intentional to go test there. You see, when you understand that you've got positive and negative testing, those give you the tools to build the boundary test. But they're not difficult at all to understand, those 3, if you can just remember to include them. But you have intent now, when you build the unit test, to say, what are my boundaries, and what are my tests specifically to check those things? And that's the whole idea. Cool. Alrighty, let's see here. So I'm one of those guys, I always like to push the boundary a little bit, speaking of boundary tests. And sometimes it drives people crazy, because I'm always asking, so now what? Where can I go with that? I was sharing with Coy earlier about an author that I love to read, Walter Isaacson. Have any of you read any of his biographies? You read his stuff? He's got a fantastic one called Innovators. And if you're a reader, you got to check that book out. And the reason I really like Walter Isaacson's teaching on this is he talks about how we learn basic concepts. If you think about guys like Edison and really amazing inventors, they took an idea that had hundreds of failures possibly, and they found those little nuggets, those areas that were, optimal, or provided some insight of that he was heading in the right way, and he continued to build on it. And so, in a way, when I thought about unit testing, my brain went there as well. I'm like, so now what? I've got these 3 things. What does it matter? How can I help grow so we can mature even better? Because there's got to be more than 3. You can continue to take this to some other level. So one of the first ones I actually learned from Jesse Orloff, one of our guys right here, one of our Java developers. And it's a test called triangulation. I had never heard this concept until probably a couple months ago, and I really love the idea of it. Anybody else heard triangulation? All right, cool. So here's that same test data. Okay, I'm going to go ahead and put my unit test in place. I've swapped out the numbers for just some variables in here that line up with this data. So when we ran our first positive test case, we put a 3 and 4 and we checked 7. Well, Jesse enlightened me to one really clever thing. What happens if the developer coded the method that always returns 7? Right? I hadn't really thought about that. And so the way that they verify that is a process called triangulation. And he adds one more test in there. So he added a 3 and a 5 that came out as an 8. And that verified at least, of course, he could still be very tricky and say if they pass this and then pass 8. But at some point, it's about risk when we're testing. This should give you a sense when you write this simple test, which is literally copying this test and changing the input data. You've done a triangulation test, and you know that method is really returning real dynamic data. It's just not hard-coded to always return a value. So I like the idea. I think it's a bump up, and it shows some maturity in our unit test strategy going forward. Thank you, Jesse, for teaching me that. Another area I thought about, kind of an advanced topic, is something called the capability maturity model. That's a lot to say. Has anybody heard that idea? Okay, right. I think CMM is how it's referred to often. And the CMM concept is that there's a natural progression to maturing, more than likely in software. This would probably apply to a lot of things, but in processes. If you think about how you first started coding, when I think about my first programs written on that VIC-20 without any storage, I'm typing it in, and I spelt 2 backwards, so the loop didn't work right or whatever, It's really rough around the edges. And you mature to some repeatable piece. For me, this is the first time I ever learned about, it was probably subroutines, was the first time I'd learned about this idea of reusable code. And it progressed to functions and methods. And then it's more well-defined. Probably some of the first programming gigs I got where someone said, build me one of these, and it was written down. And it goes on from there, from more managed and optimized code. So I took this idea of the capability maturity model concept, and I decided what would that look like if it was applied to unit testing. And this is what I came up with. Now there's a lot of print here, and I don't expect that you're going to be able to read it all. So you can get the PDF of this online, and I've got about 20 of them here with me. But what I want you to see is not necessarily all the fine print. What I want to give you an interest in doing is to see that there's a possibility to grow and mature in what you're doing in your software development. Okay? So think about this. Right up here, this is me on my VIC-20. I don't even know what a unit test is. This is all of us when we first started coding to begin with, right? And as we get more mature in our process, here, we might have even known about unit tests, and we're like, don't have time for it. It's ignored. And we continue to grow in that process. Some of the things I taught you today were in this space, positive and negative. There is some triangulation up here. You can see how there's a possibility to really grow in this space. There's code coverage checks in here, builds done, unit testing done at build times, mocks and stubs. This is really a work in progress. This is just me getting in and researching things and learning, which I have a ton to do in this space too. But as I'm learning it, I thought, let's capture it. Because if there's no target to shoot for, then how do I know, where I'm at on that maturity level, right? So I hope that this would inspire you to think wherever we're at in our unit test, there's always a possibility to grow. And maybe you're going to write me and say, hey, I know what level 14 is. We've already been there, and that's really cool that we can kind of get to that next space. But there obviously is time to mature in this. And this PDF, let's see if I've got any more on this. This PDF and the other one, by the way, you can download If you go to realworldtestautomation.com and put /unit test, this is available in a PDF. And like I said, I've got a few here for you. So some final thoughts in the unit test space. So I'm a big fan of this idea of testing early. You get greater quality at the end. Start with whatever dev methodology you're in. How many of you are using a TDD approach? Just curious. All right, so not many. So of course, its whole premise is testing early on, right? And there are development strategies that are intentional about testing early on in the process. Test-driven development is one of those, TDD, and one worth checking out. For Pete's sake, don't forget our 3 basic types of unit tests: positive, negative, and boundary. They're super easy to remember. We got the handout. You can tattoo it on your arm if it helps you. But whatever it helps you to remember those 3, I promise you, if you begin to implement them, and for Pete's sake, share it with your testing team, it's going to give them a greater sense of confidence that you're doing this low-level testing at the unit test layer. They're going to love it, and you know what? You might be the first one to teach them those concepts too. Remember about the triangulation piece, and by all means, this maturity model, wherever that would help you, I think that would be great. So, all right. Well, I'll leave you with a couple URLs here. By the way, I'd love to hear from you guys on LinkedIn. Really easy to find out there. This is the METS testing strategy. I've got a URL for it, metstesting.com. And you can find a webinar I just did for a group called the ASTQB, for any testers out there, on teaching this strategy. It's very easy to use, super powerful. At Ramsey Solutions, we're using this methodology for our manual test strategy. And I'd love to share more with it. Anybody who's interested, just let me know. I'll gladly have breakfast with you and share it with you, or whatever would be helpful. And the other one is, this is kind of my shameless plug. I just wrote my first book last year on test automation. But the handouts that you saw earlier, like I said, I've got a couple of them here. The maturity model handout is one. And this testing foundations concept, by the way, give these to your QA team if they don't have them. They should know this if they don't. You can download the PDFs on this site. Just go realworldtestautomation.com/unit test, and you can download those. And I'll also have this presentation in PDF form there. So that's all I have to share with you today, and I'd love to learn more about what you're doing. So feel free to get some time, and we can chat as well. Anyway, thank you so much.